Hey class, happy snow day. I was hoping to see you in person. So I have a little surprise for you on the screen. It's a review. I know you're so happy. I'm going to go over lessons 70 and 71 in this video, but they're very simple. It won't take long at all. So I thought this would be a good point to do a few review problems. In checking your homework, I still see some mistakes when you're doing decimal arithmetic. So, decimal multiplication and subtraction I've noticed. I'm going to review division as well. Addition should be, if you can get decimal subtraction, you should have decimal addition down, no problem. So when you do, let's start with our subtraction over here, okay? When you do subtraction and addition of decimal numbers, you have to line up the decimals, okay? Line them up and they don't get moved again after that. They will stay in the same place. They're kind of locked in place. So, but one problem that I see is when you have a shorter decimal number on top and a longer decimal number on the bottom, some of you come to, when you start your subtraction here, some of you want to take this 8 and just drop it down. That is incorrect, okay? When you have a shorter decimal number on top and a longer decimal number on the bottom, you have to put in a filler 0 there. And then you can do subtraction, and you're going to have to borrow. So can we subtract 8 from 0? No, we got to borrow, okay? So that becomes 10 minus 8, and that's 2. Do not just drop that 8 down. Make sure you put in your filler 0. Okay, got to borrow again. Becomes 14 minus, oh, no, I'm sorry. Sorry, excuse me. 4 minus 1, don't have to borrow. That's 3. That's 3. Getting ahead of myself. Okay, 4 minus 1 is 3. 4 minus 2 is 2. Here we have to borrow. 13 minus 9 is 4. That decimal stays in the exact same spot. And 6 minus 5 is 1, okay? But this is the issue I see. Be sure to put that filler 0 in. All right, let's move over to decimal multiplication. I noticed when you guys multiply decimals that in your answer you don't, some of you still don't have the decimal in the right spot. So how do we do this? All right, let's start with multiplication, starting with our 4. 4 times 9 is 36. By the way, hope you guys are still practicing times tables. 4 times 5 is 20, plus 3 is 23. Carry the 2. 4 times 6 is 24, plus 2 is 26. 0 placeholder. 3 times 9 is 27. Put down the 7. Carry the 2. 3 times 5 is 15, plus 2 is 17. Put down the 7. Carry the 1. 3 times 6 is 18, plus 1 is 19. Right? And 2 placeholders here. Our last row is easy because it's 1, so it's just 9, 5, 6. Add those columns up. Be sure you keep them as lined up as possible to avoid mistakes. 9 and 1 is 10, and 13, that's 23. Okay, 4 and 9 is 13, and 5 is 18. And that's 8. Okay, now I go back and I count how many decimal places were in my 2 factors. I have 1, 2, 3, 4. I come to my answer and I start at the rightmost digit and I count 1, 2, 3, 4. And that's how many decimal places I need in my answer. So my answer is 8 and, let's see if I can read this right, 8 and 8,306 10,000ths, or 8.8306. All right, moving on to division. I did a lot of these in class, or at least I used to when we used to meet a lot. When you divide decimal numbers, you can never divide by a decimal number, so we have to move that 2 places over. So our decimal in our dividend gets moved over as well. So it becomes 487.3 divided by 123. Okay, 123 goes into 487 3 times. 3 times 123 is 369. Subtract and we get 1, looking at my cheat sheet here, 118. All right, I've got a decimal here. I've run into my decimal. Let's put that up in our answer right away. I can now drop down that other 3. 123 goes into 1,183 9 times. And that is 1107. I did this ahead of time. I'm not doing this in my head. Okay, and we subtract there, and that's 76. Let's drop down. Now we start dropping down zeros. I'm going to do what they often ask you to do, which is to round to 2 decimal places. 123 goes into 766 times. 123 times 6 is 738. Subtract and I get 22. Drop down another 0. I need one more decimal place to round. 123 goes into 221 time. At this point, I really don't have to finish out because I'm simply getting that last digit to round to 2 decimal places. But anyway, if I wanted to, I could go ahead and subtract like that. And our answer, if we round to 2 decimal places, who's that knocking on my back door? 5 or more, raise the score. So we don't raise the score because it's 1, and our answer is 3 96/100. There we go. And that's a review of decimal arithmetic. Okay, so let's have one more review item I want to go over, and that is unit prices. All right. In class, which lesson was it? Was it 68 or so? They talked about unit prices. When you calculate a unit price, remember that for any ratio, there's 2 possible ratios, ratio 1 and then the inverse or the flip of that. So if my story problem, for example, said that Sophia could buy 30 pounds of gummy bears for $3.90, I would say 30 pounds of gummy bears for $3.90. And a second ratio I could write is that $3.90 buys me 30 pounds of gummy bears. Sorry, pounds is abbreviated, not with the S there, sorry. All right, so those are our 2 ratios, but when they're talking about unit prices, they specifically want the item, not the price on the bottom, because we want to find out how much is it per unit of a given item. So in this case, it's how much per pound of gummy bears. So we want to say per pounds of gummy bears, so we're going to look at this here unit, this rate. To find out the unit price, I have to divide my numbers. $3.90 divided by 30. Okay, let's do this. 30 goes into 3, 0 times 30 is 0. All right, there's my decimal. Sorry. Decimal doesn't go there, it goes up here in the answer. We can drop down our 9. Make sure as soon as you hit that decimal, you place it up in the answer. 30 goes into 39 one time. That's 30. Drop down your last 0. 30 goes into 90, nice even 3 times. And that's 13 cents. So if you see a story problem that says, Sophia could buy 30 pounds of gummy bears for $3.90, what is the unit price? You're going to use the ratio with the item on the bottom. You're going to do the division, and when you get that final answer, you're going to write the amount and say it's 13 cents per pound. That's our unit price. If you were to write it as a rate, you would write like this: 13 cents per 1 pound of gummy bears. This is a unit price per 1 unit of whatever item they're talking about. Per pound, per ounce, per carrot, per apple, etc. All right, let's move on into lesson 70 and 71. I'm sorry, 71 and 72. Lesson 71 deals with exponents again, as applied to fractions. So exponents were a pretty easy concept. If you recall, we take a number and we raise it to a power. We call that number here. It's an exponent, or another way to phrase it is to a power or to the 3rd power. This does not mean 2 times 3. This means take 2 and multiply it by itself 3 times. And that answer is 8. So 2 to the 3rd power is 8. Another way to phrase it is the 3rd power of 2 is 8. All right. 4 to the 3rd power is 4 times 4 times 4. And that's 4 times 4 is 16, times 4 is 64. So 4 to the third power is 64, or the third power of 4 is 64. All this lesson wants to show you is that you can take fractions and also raise those to exponents. So if we were to take the fraction 1/2, it's generally indicated with parentheses around the 1/2 so you don't get confused and only raise the numerator to the power. If it's written like this, this means 1/2 to the third power, and that means 1/2 times 1/2 times 1/2. What is that? Let's multiply our numerators and then our denominators. Okay? We can also do the same with 3/4. We'll just do one more example. Raise to the third power. Pick something besides. Square it. All right, and that means 3/4 times 3/4. What is that? 9 over, 16. So we multiply our numerators, that's 9. We multiply our denominators, that's 16. So 9/16 is 3/4 to the second power, or the second power of 3/4. All right. The next thing 71 goes over is roots. So same idea. If you remember roots or radicals, we can say the third root of 8 is, how do we read this? The third root of 8 is the number that multiplied by itself 3 times equals 8. What number, if I have to multiply a number by itself 3 times, will give me 8? It's not too many options for that, okay? Well, actually, there's only one. And it should be easy to figure out. That's 2. All right? So the third power of 8 is 2. All right? How about the fourth root of 64? What number multiplied by itself 4 times, I got to get rid of this, that does not equal 2 times 2 times 2. The third root of 8, the cube root of 8 is 2. The fourth root of 64, what number multiplied by itself 4 times gives us 64? We've done this enough. You should know it's 4 times 4 times 4. Okay, so the answer to this is 4. The fourth root of 64 is 4. Okay, likewise, we can take radicals, or we can take roots of fractions. So we can say, what is the third root of, let's make that taller, 1/8. What fraction, or what number, multiplied by itself 3 times gives me 1/8? Well, from our example on exponents, as you recall, that was 1/2. Because 1/2 times 1/2 times 1/2 is equal to 1/8. So the cube root, or the third root of 1/8 is 1/2. Let's take the cube root of, let's see, 8 over 27. What is that? All right. What number multiplied by itself 3 times gives us 8 over 27? Let's look at the numerator. We know that 2 times 2 times 2 is 8. And if we look at the denominator, 3 times 3 times 3 is 27. So our answer is 2/3. So this lesson is a review on exponents and on roots, but applied to fractions, right? Don't get too confused. It's the same process. All right, and then lesson 72 goes over something called graphing inequalities, but let me give you a quick review of inequalities. That's that greater than, less than symbol. And I know you would have done this in your lower math. So, for example, if we say 2 is less than 4, this part of our inequality symbol always points to the larger number. All right, we say if you look at the inequality symbol, it points to the smaller number, and it, sorry to use kind of a youngish type of analogy, but it wants to eat the larger number, okay? So that's inequalities. Inequalities were very simple concepts that you would have learned in lower math. 30 is greater than 20, 20 is greater than 17, and so forth. There's also another aspect of these symbols, that's the greater than and or equal to and less than or equal to. What does that mean? Well, these come into play when we need to graph inequalities. So let me give you an example. I'm going to draw a hasty number line here. How do we graph inequalities? Let's see. All right, if this is -1, this is 1, I'll just do every other one just to be quick about it. How do we graph an inequality? How would I graph 20? I want to graph x is greater than 30. What is x? I want to see a picture of what are those numbers that are greater than 30. Sorry, greater than 3. This is why I don't like video lessons. Much easier to make these corrections in person. Talking too fast. All right, let's graph x is greater than 3. What does that mean? I want to see a graph of all the numbers that are greater than 3. Here's 3. All right, I think I'll use red. Okay, so I'm going to shade a little bit of a line here with red. So I'm going to shade everything that's greater than 3. So it's a number line. It starts at 3 and goes out into the positive direction, into infinity. Those are all numbers that are greater than 3. All right? Did you find my mistake? Okay. We don't include 3. These are only numbers that are larger than 3. It does not include 3. Okay, so the open circle indicates these are numbers, this graph indicates numbers that are larger than 3, not including 3. How would I include 3? If I were to say, show me the graph of everything that's greater than or equal to 3, then I would color in that circle, because that means the graph includes 3. So that's how we graph an inequality. Let's do another one. I want to see the graph of all numbers that are less than -2. Where's -2? Here's -2. I'll do green for this one. Here's -2. So this is the graph of all numbers that are less than -2. Less means in the negative direction. If I wanted to see a graph of all the numbers that are less than or equal to -2, I would color that circle in. And that would indicate that -2 is included. It's all numbers less than -2, including -2. And that's how we graph inequalities. And they'll have to graph some of these in the practice problems. Okay, I'm not sure if I need to do another example there. Let me just check. Nope, that's exactly what they're having you do in the practice. I think you guys got that. All right, have a good day. I will be posting another video for the remaining videos for 73, 74, and 75. Try to get them all up by Thursday. All right, signing off.